The afternoon presentation is going to cover the design and performance of software-defined radio systems, from direct carrier generation to the use of units incorporating the GNU radio design software. It'll focus on experience and actual use of equipment on all bands from 80 meters to 10 gigahertz, and some of the benefits and difficulties associated with SDR operation. The emphasis will be on low-cost solutions, their performance and test equipment needed to implement them. Okay, so that's what the talk is. And Gordon Lean, ARCS CEng FIET, has spent over 60 years working with radio and communication systems, initially installing small relay antennas through to megawatt transmitters and satellite systems throughout the world as head of engineering for BBC News and general manager of BBC Transmission Engineering. Keenly interested in aviation, is also a director of several avionic companies supplying equipment and maintenance to all sectors of that industry, from microlights to military systems. A UK member of the various international committees, EBU, CCITT, Intelsat, RSGB credits include first microwave contact between the UK and the Channel Islands with Dr. Dane Evans, the Fraser Shepherd Prize, the Constructors Prize from 1975 and 2020, and the Ostermeyer Trophy. So, with further ado, I'd like to introduce Gordon. Over to you, sir.
Right. Well, I won't get into any of this. Throughout my career, I've tried to be as simple as possible, and other people can do the complicated bits. And that's exactly what happened here, I'm afraid. But I've pulled it together from some very clever people. So, firstly, first slide. That's, if you were in this morning's lecture, you'd see what I actually use and the way it's progressed from a shack-in-a-box bought system to what I'm using now, which is just a receive dongle and a hack RF SDR converter from USB into RF. And that's all I'm using as the basic system, plus an amplifier and a coax switch. So that's my screen at home. Now, this is on an old Linux box, and I'll just point out quickly the different things. This is my transmitter, which I've done myself. That's about the only bit of work that I've actually done. I haven't written the software. I've used GNU radio to put blocks together with little lines between them, and to produce Python software which runs on the computer, on this Linux computer, and it produces this graphic and the way it all works. This is GQRX, which is a same thing but for a receiver, but I didn't make it, some genius did, and that does the complete receiver from well, it depends on your receiver dongle or whatever you fit into the USB socket. I use a RTL 4, I think they're 492 or something like 1492, but they're in a metal box, a little tiny metal box, a USB, no bigger than the fob you fit in the computer, and that is effectively what I'm using for my receiver. And don't think that it won't do anything else that other software can, but that software comes with any Linux box, and I didn't do anything for that. That's just out of the packet. Well, it's not a packet, out of the download, should I say. And then if you're using a PC, you can go from one thing. When the receive output comes from this, goes internally in the audio to the WSJT FT8, and there's the FT8 output, and you can use FT8 in the normal manner. That's using as many things as possible on the thing. If you can go to the next slide. So it just shows I'm all on one big PC. So there's my bits and pieces. There's the RTS dongle, and there I'm using a hack RF because it's the cheapest that I could lay my hands on, and people were even selling them second hand because they've been out so long. And it's all USB, so it's USB for a receiver and USB for a thing. There's no controls on this whatsoever. Everything has to be done in software. And this little black box here is a 3-watt amplifier that does from top band to 77s. Well, I don't think it does very well on top band, but I think it certainly works on 80 meters. And that gives me the same as my bought shack in a box when it's on battery. So it's about 2.5 watts here somewhere. That comes out of there. Now I've also got, you can buy online some small amplifiers that do about, it says 100 milliwatts, but actually 50, all the way to 4,000 megs. So the whole thing can be all in one, from HF to 4,000, but depends on this here being. You can buy these now. I think they'll go down to 3 megs, and again, it's beer money type prices. Now, one of the important things is to have that when you're working on, as I've had to do, to build my own transmitter software from GNU Radio, which is an application which only runs on Linux. But it also runs on Raspberry Pi. And I found with the Linux that I got it all working, all marvelous, up to about version 19.3, and then all of a sudden it stopped. And that's because they changed the way they do call instructions into Python. And as I know nothing about the actual details of the software, that was the end of that. So I said to myself, I'm never getting into that situation again. And that's why I chose the Raspberry Pi, because all the software, including the firmware, well, not firmware, but the operating system, is on the little fob, and I use a 64 gigabit fob plugged into the Raspberry Pi, and that's it. And sure enough, within a year or two of me starting on the Raspberry Pi, they changed the software so that it was different. But now they've reintroduced the Buster software onto it as a legacy version, and I've just tried that again, and that now works again. But of course, the important thing, and I must stress, is to have all the software on a little fob that you can move from one box to another, or say, well, this is my radio, just like you would buy a radio. That's my radio. Here's a Raspberry Pi with that version in it, because trying to keep up with versions on Linux is just impossible. And this other bit of kit here was just another USB to a piece of wire, basically, so that when you do a call on the USB or from socket, whatever, I can get a 0 and a 1 on there, so for whatever, or vice versa. But as I'm not great into writing software, I just use that for the PTT if I need an external PTT instruction. So if we go to the next one, that is the software that I wrote. It's the simplest possible version of the software I wrote, because this is just basics. Now, I tried every conceivable method of generating an SSB signal, from a Windows PC with some famous software on it which does transmit, and they talked about that this morning. I can't remember what that was, but anyway, it worked, but it didn't work well enough for what I considered to be an amateur radio decent signal to do all sorts with. So I concentrated on GNU Radio, and the fact that you didn't need to know anything about software writing for GNU Radio. All you need to do is put these boxes together and link them with a little arrow. So the only thing you're actually allowed to do on GNU Radio is assemble. Down the left-hand side here is a menu of all the little boxes that do things. And so all I have, well, I say all, but I tried every I'm a bit on the multiple idiot method. I try everything and just keep going until it works. I just adjust each parameter a little bit and see what the improvement is, and don't have anything to do with theory, because whenever you try theory, it never works. So I always try something practical and say, you know, I'll try this, move it up and down, and see what happens. And I managed out of this to get a reasonable signal, which you'll see in a few minutes. And this is based on my previous knowledge from 50 years ago of how to make an SSB transmitter, which is, you start with an audio source down here, if you can see this. You have a volume control for your microphone, or whatever the audio source is. This is a complicated business which I don't fully understand, but it does improve the linearity from 8-bit into a number which can be, up to something like 15 or 16 digits or whatever it is. But I've also found I've reached the limit of that if you start going above 9 centimeters. But anyway, so with that, on an old-fashioned radio, you would have your audio source, you'd mix it with your 10.7 meg IF generator, and then you would come along and mix it up to your final frequency. So that's my old-fashioned knowledge way of doing it. And so what I've got is a signal source here. Its frequency is 0. Don't ask me why, because that was the way it works. That multiplies, which really in old-fashioned software or old-fashioned analog value is mix, and out comes here a dual sideband mixed frequency, if you like. This is all done in numbers, so it doesn't mean anything when I say a frequency or whatever, but in my simple mind, that's the way it works. So on there out comes a dual sideband signal at one frequency. It happens to be 0. But it's a dual sideband, and this thing is the master thing, and that was already there in the box. You just pick it up from the right hand side, stick it in here, and join it with the other signals, and then you have to fill in these numbers. So I make the gain 50 and the sideband, upper sideband or lower sideband, and you can have the sharp cutout rate. You can have 2.7, you can have 2.65 kilohertz width. You can have anything you want, as long as you put numbers in the boxes. And then the other clever thing that GNU radio people have done is allowed for a very minimalist mathematical equation to go in some of these boxes. So when you make a bandpass filter like that, it says lower frequency cutoff 300, upper frequency cutoff 2.75 megahertz, kilohertz, sorry. So there's a standard filter. But if you want the inverse of that, a lower sideband filter, you do the opposite. You say lower cutoff is 2.7 and the upper cutoff is 300, and that will give you a lower sideband. But the interesting thing, you can put some little equation and say, if switch up here equals lower sideband, then do this. And if switch is lower sideband, do that. So you can actually have a switch to switch the sideband. And these boxes up here are switches, basically. They're all switches. Or there are sliders. You can have switches or sliders. They call them choosers or sliders. And you can make the switches up as much as you want. And so out of it comes here. It's resampled again and bangs into the Osmocon driver. And that is for HackRF or a Red Pittier or some of these. But I've only tried it with HackRF because I can't afford all the other stuff. Well, I don't want to afford them. And out comes anything on the HackRF between about 3.5 megs and 5.8 gigs. So you don't need any band switching and all this rubbish. You can just decide with a little mathematical equation or thing here and buttons up the top here what frequency and what band you want to go out at. There's not much output out of 5 gigs. It's sort of minus 10 dBm or something. But normally anything below that at sort of 9 centimeters or whatever, you get 0 to plus 10 out of the HackRF. So the next slide. And this is now using what I'm using. This is last week's rig, if you like. I'm using a Raspberry 400 because no other reason other than the thing has a keyboard, and that would be yet another thing to plug together. And there's the receiver, complete receiver there. And there's the transmitter. But what I am actually doing on the transmitter is going out and going in this 20-watt amplifier that I made down here. And there it is. I tend to go on 4 meters because there's not many 4-meter rigs out there, and I like to do contesting, and I don't want a lot of competition. So I like to be on 4 meters, which everybody finds hard to do for some reason. And I've got all the other kits that you can buy for 4 meters, but this is by far the best. And one of the reasons is that I can see the entire band that people transmit on in the contest, and I can just click on any of these signals and it tunes automatically to it. Enough, if you've got a nice big screen, 20-odd inch screen, for you to get spot on without having to worry about tuning the last few 100 hertz or whatever. I can just listen to people, and also you can see what they've been doing, and you can recognize people calling CQ in this, and so you can just search and pounce, bang, click, we're on. Now, the important thing on this is to notice that little grey thing up there. This software comes free, downloadable, or in some of the versions on Raspberry Pi, it's already installed. So you've got a complete amateur radio receiver already installed. You only need the dongle. And this little grey thing here puts the information of that box there, which is the frequency, out into a port in the PC. Don't ask me to say what a port in the PC is. I have no idea. But I do know somebody that does. And they wrote me a little software thing to extract the port information on there and put it into my transmit software, which is this thing here on there. And so when I jump from one frequency to the other, the transmitter follows it or not, depending on whether I switch that thing up here. So I can have full duplex with different frequencies, or I can be on the same frequency and jump about and the transmitter goes with it. If we go to the next slide. Right, now, how good is it? Why? Oh, it says up there, how good is it? Sorry, it's the way the PC is, their PC is pulling out this thing, this problem with the blue. So anyway, that's how good it is. And the important thing, if you look up here, there's the peak, and this is the noise, and this is about 70 dB, down about 60, 55 to 60. We're starting to spread outside the bandwidth of there. But that's the same when I put in my bought multi-rig. I get about exactly the same performance. I can't get any better out of theirs. I can't get any better out of mine. But it's clean. When you look at that, it's absolutely clean. No side lobes on it. And so you recognize somebody who's not being nice on the radio. It's as clean as you need. And then on my little tiny spectrum analyzer, which you can now buy for next to nothing, a few pints of beer, I can see that that's on 70 megs. There's nothing else because I've built a low-pass filter, and that little amplifier, the 2-watt thing, produces pretty much a square wave. So in actual fact, it's down only about 20 dB on the third harmonic. So you've really got to filter it out. So anyway, so there we are. How good is it? It's as good as anything else. It's not the best, but it's as good as anybody else can get on their bought kit. So the next slide. Now, let's see what other people are using with their bought kit. This one here, you'll see it's absolutely square, no bother at all. This is on 2 meters, as you say, on a very recent contest. This one here, awful. It's 3 times the bandwidth it should be. And when I look him up, I find he's using the most expensive kit that you can possibly buy. We're talking 5 figures. And so what's he done? He's gone and overdriven the amplifier. And so this thing, you can see here, is only from there to when it spreads outside the band, it's not even 20 dB. So that's actually illegal. Because it's outside your terms of reference. It's only 1% of the bandwidth of the signal can be outside the bandwidth. And of course it comes out right out here, completely drowning any signal that would be in that, which he was. And that's just taken from a random sample. There will be 1 or 2 people operating like that, and there'll be many more who are just using your radio, but this is just overdriven amplifiers, and the last slide will show you what I mean by that. So the next slide. So we now know that it's as good as it needs to be, and it's a lot better than a badly operated other piece of kit. And this is now in a sort of, that's my normal contest mode. I have a logging software as well down the bottom, and that's on my 2 meters, and that's more or less. And you can see how other people's signal are really clean on 4 meters. It's a nice band. And as soon as I adjust things on my software, I'm told about it on 4 meters. So people say, well, it's not as good as it was yesterday, or it's coming off. And even at 400 kilometers, they'll say, no, it's not as good as it was. All right, and I tweak it and it's fine. But not necessarily can people do that with this commercial kit. So, but because I'm always tweaking, I'm always using amplifiers and fiddling about. So people tell me when I've got it wrong. But it only takes, and I can see immediately on my set, because I've got duplex, whether I should even transmit anything. So anyway, the next slide. And can I do contesting? Yeah, I can do contesting. It's not as good as anybody else's winning score. Chris is always up at the top there, and I'm in the middle. But I can still get me 400 kilometers, but that is using a 150 watt amp, and I'll come back to that later. So I can do as well as anybody else, but not in the top league, although I did win the FM and the whatever contest, but that wasn't 100% SDR. Can we go on again? That's the same slide as before, and I was going to, no, it doesn't come in. I'll have to go to the next slide. That's it. Now that is the actual software I was using for the 4 meter contest, so it is slightly more complicated, but it's only complicated because I'm adding loads more switches up here to give me different bands, and I'm also adding the complete thing all over again down the bottom here as an FM. So I've now got switchable modes, switchable bands, and everything all in the one block. And also, I've added an extra bit here, another bandpass filter, because I generate a carrier on my microphone at 6 kilohertz, sorry. And so when I want to transmit, I press the microphone button, it generates a 6 kilohertz signal, and that's filtered out, but at least it triggers the transmitter to transmit. Now, the reason I'm doing that is only because I'm not very good at software and don't know how to collect that port thing that I was talking to you. But I have an idea for it now. With using the Raspberry Pi, you can get access to actual pins of voltage, or you can use that little plug-in USB to SDR. So, but that's the full Monty there. Next slide. Now, also, because I'm using SDR and it's duplex, it's very easy to use it on the satellite on eSail, because there's my transmitter, a different one again, and the software's all different, but it's based on the same software generation, and I've added two-tone tests and voice keys and all this other stuff that people can do. It's only a question of adding a box. But this is my signal here. It's very clean, and it's the strongest signal on the band. You can't go anymore because that's the beacon. You're not allowed to be above the beacon. But that's using an extra power amp on top of the little amplifier at the 100 milliwatt stage amp, so I'm using 5 watts. But with 100 milliwatts or the 50 milliwatts, it's good enough to see a signal there, and you can do it on CW, so you don't need to go mad and go and buy a massive amplifier. You can actually do it with this £10 all-band amplifier and get up to the 2.5 gigs that you need to transmit. And again, if you look at the top, it says 10,300, but it's not receiving at that, it's receiving at the intermediate frequencies of the LMB that I've put up there, which is it's not octagon LMB from a normal telly, but it's got a high precision little crystalline. Everybody in the microwave world uses those. But so in other words, I've used maths in the GQRX to say that there is an intermediate frequency, and there's maths between what this is receiving on 600 megs to give me the true output on 10,004. And then I'm using the little buttons up there to transfer that to the transmitter, and more maths to say the transmitter should be the IF of the transmitter different. So the whole thing is all locked together or not, depending on whether I click this button up the top. Next slide. Next slide, we've got it. Oh, sorry, did we go back? What was that? Oh, so then also in this completing the SDR, the digital cycle, you can also operate digital modes on the same PC and arrange for the audio to come out of this GQRX software and go into this. I'm using this JS8, which is, I like this mode because you can actually have a conversation with somebody at the other end of the world whilst at the same time only using 20 watts. That's a full digital, so if you have not used it before, it's like WSJTX. It's based on that, but at variable rates of digits, and the fact you can actually text people in a normal way, and you can have a proper conversation. How is the weather there in Japan, you know, tonight, type of thing, and it's okay. So you can do the whole lot with its logger and everything, all on the one PC. So if you go to the next slide.
What was that software again for doing?
What's it? It's JS8. It's just like WSJ, and it's all downloadable, and I'll use it on any set. But it's FT8 with capability of proper conversations, and it's about 3 dB better because you've got an option of having very, very narrow bandwidth. And I find with 20 watts, I seem to be able to get, on the next slide, anywhere I want. So I can have conversations with people in America as opposed to just get a thing. Also, the JS8, if you set your JS8 to automatic receive, people automatically send you things back, even if they're not in the shack, if they've left the kit on. So you know immediately, unlike the other one, that you've got there, and not only that you can hear them, because they send you a message back. So immediately you know that's what my range is. I can talk to any of these people on there, and I can talk all over Europe in a normal manner. So the next slide. And just a final thing about the amplifiers I promised was this is the amplifier I'm using on what I'm using at the moment. I've also used what was called a 45 watt amp, and they're all home built from kits. So all the bits and pieces came, not the top bit here. I built that. That's just the filter is built in because I only work this on 40 meters and 10 meters, and I use this in Australia. And that's just a VSWR thing out of the RSGB bulletin from years and years ago. And so that's a 65 watt. Now, a guy in Watford sells these as a kit. Now, this is a bit on the difficult side to build, but it's a 600 watt. And that does HF all the way to 70 megs. And I've been playing with that this year. Now, the point about these amplifiers, they're all the same. They all use, this one I've changed the FETs to a bit more reliable one. I've changed the FET to a proper RF one at about 4 times the power that it should have. And what these all do is produce basically square waves out of these final toroids, and they're all filtered with this has got a one of these VSWR things inbuilt, but you have to have a complete filter assembly out of it. And if you work the maths out, if you produce a square wave, the third harmonic is only 10 dB down. If you work all the Fourier analysis out. So it's horrendous power comes out of these sets on the third harmonic, on the fifth, on the seventh, on the ninth. And if you add it all up, it comes to equal to the power that you're actually generating on the fundamental. So when it's called a 65 watt amp, it's somebody putting a power meter on the end of it, and powering it up and says, yeah, I've got 65 watts. This isn't 65 watts at all. It's 30 watts, if you're lucky. So I'm operating that 25, 30 watts max. And in the same way on here, instead of the, when he does the tests and everything, and it's the same for the manufacturers and everything. I've been a manufacturer, don't worry about it. Everybody quotes what the amplifier actually does. And in actual fact, on a nice pure signal, that will give me about 250 watts. But on 70 megs, we're only down to about 120, 150. If I go above that, I get that awful business that we saw on the other thing, where somebody's bought a 400 watt amplifier and tried to operate it at 400 watts, or whatever their amplifier was. They're way over. So you've really got, whatever amplifier you've got nowadays, you've got to almost divide it by 4, because even if you divide it by 2, is half of it was all the harmonics that have got absorbed in the filter, and the filters bust as soon as look at it if they're not powerful enough. So that's the words on the amplifiers. The little amplifiers that I was using, the 2.5 watt, that's not a great problem, but they're quoted, of course, at 4 watts, or this is what they sell them at. But of course, they do produce, and they're not lying, and they do produce 4 watts, and that does produce 600 watts, but not at a level which you should be using it in competition on the thing. But the manufacturers have already taken that into account when they put their 50 watt amplifier out. So they tend to have done, so you think you're getting something big, which you can get, but you really mess up the band if you use them. So the last slide now. And there's a comparison. There's my little SDR here. And there is somebody's test on a commercial equipment, driving the amplifier to the maximum the commercial equipment is bargained for. And if you look between what I can get out of the SDR on this 600 watt amplifier operating at 120 watts, virtually the same performance as they're getting for 50 watts. But we don't know from the manufacturer, or nobody knows. They probably would tell you what their amplifier is actually rated at for as an amplifier. It's probably 100, 200 watts in there as a chip, but when they're actually getting this performance out of it, it's 50 watts, and that's what they're selling it at. So when you're buying a manufacturer's stuff straight off on a proper amateur radio set, that's what they'll quote it as, and that's as bad as you can be. That spectrum there looks awful, but it's because I'm using two-tone test at half power, and that was the same thing as I showed you earlier with the very good spectrum on the band. So it's exactly the same as a commercial bit of kit, and that's how bad it looks when you're doing a two-tone test, but it looks pretty good on 4 meters on a commercial piece of kit, and so does that. All right, the last slide, and that's, oops, I don't know why it all jumps up and down. Must be that software. It's not my PC, remember. Anyway, if you go to the September-October 21 Radcom, then you'll see further things that I did on the HF version of the thing, and also you'll find the websites and things where you can download more information, which I've put up in there to download the basic transmitter power thing and everything. So anyway, anybody got any questions now?
Questions?
Silence.
No.
I've not baffled you. Can't baffle you,
No.
sure.
No.
Gordon. Now, okay, Gordon. With the software, do you use any piping software, or you directly connect to each individual module?
What happens in GNU Radio is you open up GNU Radio and it gives you the choice of all these boxes like FM. There's even one box saying FM transmitter, and you just put that on the screen, call it something, and put an output line to whatever type of SDR box you have. I'm using Hack RF because it's the cheapest. You just draw a line across, touch it, and then you draw a line to the microphone, if you're using the FM transmitter module, and that's it. And then you press go, and it doesn't do it. What it does is actually generate the code in Python. And it's gigabytes. Well, it's not gig, it's 10 megs worth of code, and it's unbelievably complicated. But so I know nothing about that. I press the button, and if it comes up green at the bottom and it works, it works. And if it doesn't, tough. I haven't got a clue. So that's the way I work. Now, when we did the... is there another slide after this one? No, it isn't. This morning I had a tribute to the people who helped me do this. And one of the guys, Dave, FKH, isn't it? That's his... FKH, isn't it, Carl? Yeah. He wrote a little piece of software which took one of these boxes out of GNU Radio and communicates it with another port within the PC, and he's done all that for Minos as well with the way you've done it. So he did it for me for this, and that's how I get my link between the receiver and the transmitter. The data goes from one to another. It's not a very big Python program, it's only about 10 lines, but it does take that. I haven't got a clue how to do it. I just got, he offered to do it, and I took him up on it, and it all works.
Okay, thank you, Gordon.
Any more questions?
Somebody
Yeah, just a second.
That's your credit slide.
Oh, there's the credits. You see, these are. I mean, I can't take the glory for doing it all, because all of these people did bits and say, "Why don't you try it?" Well, what I do is do like a monkey. I press as many keys as I can with all this software and all this stuff, because I've got time on my hands and I can just do it, if you see what I mean, and I find the best solution. As I say, started out with the Windows thing and saw the spectrum out, oh God, can't do that, and so on, and I worked my way. And the guy, Dave, FKH, wrote the Intercept program, and the various other people got me the ideas of why don't you try Hack RF, and why don't you try the RTL dongle, and Carl was there, so Arduino's good for your changeover, why don't you try that? And then Anthony says, oh, I've done a bit of software for that already, so oh right, thanks very much, and so on, and it just built up from all these people in the club just doing the same thing, and it was good.
If I may, it's David G0EVV. Just a thought about the amplification, the final amplifier,
Yeah.
and the problems of amplifying square waves. Is there a solution in putting a filter before the amplifier?
Well, I
so
do that anyway.
You do, right, big time then, a big filter there. Yeah.
Yeah, I've got a little tiny one on each band. 70 megs, I've got one before. In order to get that, I've got one before out of the 2-watt amplifier, and then into the 71 as well. There is, but some will work straight away and just chop it all off at the end.
Yeah, I understand. Yeah.
You know, I mean, but the proper way of doing it is what you've just said,
Right.
and that's why I'm doing it on the 600 watt, but I don't bother with the other. You can get rid of it.
I built a filter for that, which was a diplexing low-pass filter, so it actually diverts the high frequencies away to a dummy load.
Oh,
and
no,
therefore
that's...
gives you a good solution as far as the previous amplifiers concerned, for dynamic range.
Well, my amplifiers are quite small, so I just hope. But I am on my 5th set of PA transistors on the 65 watt one. But that's due to finger trouble, and that's forgetting to put the right filter on the right frequency, and so on and so on.
Anybody else? Well, thank you, Gordon, for that. That's most interesting. I think we've all learned something. Yeah, and I think everybody looks forward to doing a bit of experimenting. Yeah, and dragging a few lines across to join all these function blocks and looking for the green light.
But the easy solution is just to use the receiver out of the box on the Pi 4, you know, and buy a dongle.
Right. Can you show your appreciation, please, in the usual way? Thanks a lot, Gordon.
Thank you.